Hi everyone, we are here at the Hanlon Financial Systems Labs at Stevens Institute of Technology, Hoboken, New Jersey, across river from Manhattan. Today we invited three of our PhD students who are working on recently applying deep large language models in financial applications. Let me start with some ways we heard from the industry and academia recently, including Jeffrey Hinton. In one of his talk at the Vector Institute, he mentioned that it is probably not a good idea to open source training of the large language models and maybe in the future AGI to avoid the risk of superintelligence falling into the hands of bad actors. But here in the lab, we now use open source and openly available pre-trained large language models to build financial applications in our research every day. And in the future, we think more and more people, and we will be more and more depending on open source large models. Why don't we let Hanlon talk about his project as an example?
Yeah, thank you, John, for the kind introductions. I think recently we have witnessed the large language model agent has been attract a lot of attentions. They have been applied in many fields, including the code assistant, web browsing, but we haven't defined any large language model application in finance. So our research paper filled this gap, which is accepted by the LLM agent at ICLR. In that framework, we build autonomous trading agent that use a large language model as inference engine to understand and perceive the market news. And what makes our framework unique is that we build a human memory system that's can help the agent to store the important informations, and most importantly, to adapt to the timeliness of the financial market. The memory event will decay, and some important memory event will be reinforced if they find it important. And I think Hanlon Lab has been provide us a lot of help to set up the devices and give us the necessary computational resources to simulate the market.
Yeah, thank you, Hanlon. As far as I know, your project is one of the first attempts to use large language models to build automatic stock market traders. And you used a simplified environment to test it. What about the cases where we want to manage a larger size portfolio or to apply it in a more dynamic, more realistic environment? I know, Yang, you are working on a project into that direction. Why don't you tell us more about it?
Yeah, absolutely. After Hanlon and we together develop a single LLM-based agent system for the identical equity trading. We do feel this space, there is still a huge space to be further explored. And we consider the further explanation can be vertically and horizontally. So following the vertical direction, since we noticed the single agent system is very good at handle a single task, such as single asset trading, and we begin to think, why not we just incorporate multiple LLM agent to do a collaborative work so that it can handle more complex and sequential decision making, sometimes even good at optimization problem. So that's our initial thoughts. The other direction is we noticed the researchers, no matter from academia and industry, they have the urgent need to see a comprehensive agentic workflow benchmark. Since we have accumulated a lot of experience on developing the LLM agent in financial domain, we think it's a very good chance to develop this kind of benchmark on our own. So therefore, we eventually developed a benchmark work which can incorporate different types of financial products trading. At the same time, we can handle the large portfolio management. So the outcome is pretty good. For our first project, the multi-agent project, it has got accepted by the NERP's main conference this year. And for the second project, we just finished it, and we are planning to submit to the ACL early next year. And during this process, as you may notice, there is a huge request to us to deploy some open source LM into a lot of GPUs so that we can accomplish this huge benchmark. And we really want to thank Hanlon Lab to offer us many numbers of free GPUs to use. And speak about the future work, I think for our current version of the benchmark, we only incorporate the commonly used financial data types, such as the test data like financial news, and table data such as stock prices, so on and so forth. So I think in the future it will be very impressive and interesting to see what if we incorporate other modality data such as conference call audios and financial charts. That will be our next version of the benchmark. Yeah, thank you.
Yes, thank you, Yang. Congratulations on the NIPS paper. And a funny story I heard before from Hinton, he and his students actually got rejected in the early 2000s by NIPS. The reason he got was that there was already a paper about deep learning accepted. So 2 papers is too many for NIPS in the early 2000s. So that's a very impressive achievement. So I know your project and Haosang project are based on inferencing or the publicly available large language models. What about the cases where the publicly available pre-trained large language models are not good enough, or in some cases not necessary for some financial applications? For example, where we can train a smaller, deep large model to approximate one function in a traditional method, in a traditional framework, in the case where the real world doesn't satisfy the strong assumptions required by the traditional method. I know, Yupeng, you are working on some project into that direction. Can you give us some details?
Yeah, sure, of course. In addition to the inference-based project, we also can fine-tuning or pre-training the large language models on each 100 GPUs. And today I will introduce the 2 projects that involve the trainings or fine-tuning steps. And firstly, just Yang and Haohang mentioned that we already deployed a lot of large language models on our H100 GPUs, and our proposed agent-based framework takes a lot of hardest financial decision-making challenge and tasks, right? And currently, we are trying to fine-tuning the backbone large language models under our frameworks by using some specific data for enhancing the agent framework's decision-making capacities. And that is our ongoing project. And secondly, we have collected a lot of financial audio data from the earning conference calls. And we are trying to training some multimodal large language models for financial audio analysis. Yeah, that's our second project. And the second project has been accepted by the International Conference on AI in Finance. Yeah, and based on our previous project experience, we both of us feel that training or the fine-tuning steps is necessary and important for the overall performance improvement. So yeah, and also definitely for the future, we believe that the open source, like the pre-training or fine-tuning project has a huge social impact, the potential huge social impact for the lot of domains and different tasks. Yeah.
Yeah.
Thank you.
As you can see, these are all very good examples of using open source large language models to build financial applications. We are not trying to build AGIs, right? We are not trying to let super intelligence to overtake human jobs, but we are trying to make applications that is urgently needed by the industry. So that's why we here in the Hanlon Financial Systems Labs are providing our community with free resources like GPUs and also a lot of historical financial data sets. Try to bring everybody here to have more collaboration and more to inspire each other to bring the full potential of AI in all kinds of research fields. Congratulations to you guys on the papers published. And I know that you guys will be heading to some conferences very soon. So next time, hopefully you guys can bring back some new trends from the academia and the industry and talk about and share with us. All right, and thank you again for taking the time to join us, and see you next time.